Hey there, I am Andrew Dietering, and this is Scale Counting Automation. What we have here is a machine that will autonomously bag your parts, seal them up while you're sleeping and not working at all. I primarily worked on the embedded code for this project and helped the team do the overall physical build.
Hello, I'm Devin Mooney, and I'd like to talk a little bit about what I worked on this project. I was primarily responsible for all the wiring and the mounting in this electronics box. And I also did quite a bit of work on the counting system here. I machined all these pieces in the machine shop and mounted the servo and did quite a bit of testing to make sure that it would detect the right weight.
Hey there, I'm Sean Stalley. I primarily worked on the GUI and all the computer side code for this project. I also did quite a bit of work on the bagging system, as well as helping the rest of the team with the whole physical build.
This is our block level diagram. The delivery system takes in pre-sorted hardware that is loaded into the top of the machine. It then delivers the regulated flow of hardware to the counting system. The counting system is where the hardware is weighed. Once the hardware is weighed, it is then dumped into the bagging system, where it is sealed.
Okay, our delivery system consists of a hopper and a chute. This hopper carries all of our hardware that we're going to bag. Right now it's full of 1/4-inch nuts. There is a door on the hopper that lets us vary the size of hardware that's coming out of it. The chute has got this noise insulation foam, basically, because it's really loud without the foam. Here's our vibration motor. It's just a straight DC motor with a weight offset. And then the microcontroller will vary the speed of that motor depending on how much weight we have in our basket.
This is the counting system of our machine. It consists of a bin to hold the parts as they come down. Has a servo to dump the bin once it's reached its weight. The weight is determined by a load cell here. It's controlled by the microcontroller. And I'll demonstrate how it works here. So the parts come down, they fill up, it automatically dumps, and then goes into the bags. Alright, this is our bagging system, or part of it. The bags come in off the roll from this side. They go through this printer assembly here, and we modified the motor for this. We put in a stepper motor, and since the stepper motor got hot, we needed to put a heat sink here and a fan on the outside to keep that system cool. And then the bags come out this side.
So this is the front end for the bagging system. Once the bags get up here, we have to know that they're ready to have parts put in them. So we have a sensor right here. It's just a little switch. So when the bags come up, it gets caught by this thing, which engages that switch. That way we know the bags are ready to be filled. Once the bags are filled, we move them down and we seal them with this linear actuator and the sealer. The linear actuator just acts like an arm would, pushes down on the sealer, seals the bag using heat, and then pulls it back when we're done. And that's how the bags get sealed.
The graphical user interface will be on an external computer and takes in the type and quantity of parts going through the machine. Once the user has the parts loaded, this information is put out to a microcontroller. Microcontroller starts the whole process by sending out logic signals to each motor. During the process, there is feedback from the counting system to the microcontroller such that the current weight is known.
So this is our GUI. You can choose whatever kind of part you want. Let's say we want to do 1/4-inch nuts. You can just choose a nut and then the size 1/4-inch. Choose however many parts you want. Let's say you want to do 100. Let's say we want to do, 25 bags. And so once we hit start, the machine will run and make that many parts. If you want to add a new part, you click this and a little screen comes up. Let's say we want to add a new type of nut. Let's say we want to add a unicorn nut. And then you just have to put in its weight in grams, and you can create a new part. And if you go look under the nuts column, there's the unicorn nut. And it's just as easy to remove them. You just hit remove, you look over here, the unicorn nut's no longer there. And that's our GUI.
Okay, the microcontroller system just consists of the Atmega 128 board that we use for everything here at Oregon State. We're mainly using the UART interface for PC communications. Down here you'll see the analog to digital converter. That's all done through SPI on port B. And all the other connections go to the motor control unit.
Unfortunately, the signals output by the microcontroller are simply not powerful enough to drive the motors directly. Because of this, we need the motor controller system. The motor controller system combines the logic level signals from the microcontroller with external power to create signals strong enough to drive the motors directly. The frame block connects all of the subsystems together physically. It also encloses the entire project for safety. The power supply and distribution block takes power from an outlet and gives all the electronic components the power they need. So the motor controller block, all it does is takes the signals sent out, the weak signals sent out by the microcontroller, and sends them up to line levels to get sent out to the motors. The motor controllers control all the motors except for the servo, which does all this internally. One issue we came up with is that these chips right here were getting really hot, the driver chips, because they do a lot of the lifting. So what we did is we doubled them up and made them twice as thick. So there's 2 chips there instead of 1, which doubled our current output.
This is the power block here. It has a power strip, and these wall warts plug in and supply power to the box. Over here on this side, we have the emergency stop button. This is in case of an emergency. You can turn off the machine quickly. We'll go ahead and turn it on here. And when it's turned on, you can see that the power supply system is putting power through this plug here and into power the various systems. And these are the output plugs that go to the motors. We're going to be bagging 100 quarter-inch nuts.
Our advice for next year, one thing is get fuses. Fuses are only for people who make mistakes, and you will make mistakes just like we did. We ended up blowing up a bunch of these things that are pretty expensive to replace. Another piece of advice, start early. Go over winter break. Don't assume that just because you're not in class doesn't mean you shouldn't be in school. there's going to be a lot of bugs, and you're going to want to try to fix it. Another important thing is pick a good group. Pick people who are going to get the job done and get it done well. That was one of, I think, our biggest advantages. We had a very solid group to begin with. We knew each other very well before coming into this. That's my advice.